In this video we will learn about the theory of consumer choice. Now we'll start the video with a brief introduction to budget constraint and some examples that follow. We talked about the trade-offs before. We know that when you buy more of one good, that leaves you with less income to buy other goods. Or when you decide between work and leisure, then the more hours for work leaves you less time for leisure. Any decisions involve trade-offs, yeah? So as consumers or as rational decision makers, you make the optimal choices or optimal decisions. When you're making these trade-offs, there are a number of assumptions that we have to make about your behavior. First thing is, you as a buyer or a consumer, you are rational and you prefer more to less. And also, as a buyer, you seek to maximize your satisfaction, or as economists say in a fancy word, utility. We will come to that in a minute. And you are acting in self-interest and do not consider others' satisfaction or others' utility. So remember, we are sort of acting on our best interest or on our self-interest. And however, we always face what we call constraints. So we may want to buy, the most number of supercars or the best houses, but we are always constrained. So there's also always limits on the consumption bundles that we can choose. Maybe we should demonstrate this idea with two good examples. That makes things much more clear and simpler as well. So let's move on to the example. And with this example, we will try to answer 4 questions here. So let's read this. So Russell basically has a $3,000 income, and he splits this money or spends this money on 2 goods that he consumes. So that's steaks and avocados. Prices are for steaks $10 per steak, and for avocados is $2.50 per avocado. Now, by answering these 5 questions, we will learn the concepts that are important or useful in the analysis of consumer choice and optimization behavior. So the first question is, if Russell spends all his income on steak, how many steaks does he buy? B, if Russell spends all his income on avocados, how many avocados does he buy? C, if Russell buys 200 steaks, how many avocados can he buy? And plot each of the bundles from above on a graph, steaks on the horizontal axis and avocados on the vertical axis. So by answering these questions, we will learn important concepts here. So this is the solution. Right, so let's get started with answering the questions. So the first question was, how many steaks could Russell buy if he spends all his income? So in this case, it's $3,000, given a steak costs $10. So we take all the income divided by the price of steaks. That gives us 300 steaks. On an XY plane, where we plotted steaks on the horizontal axis, it is this point here. This point A is showing us the number of steaks that Russell can buy. On the y-axis, similarly, we have the quantity of avocados. And this point showing us the number of avocados Russell can buy when he doesn't buy any steaks. Yeah, so the second question basically is about that. So again, if he spends all his money on avocados, how many avocados will he buy? So basically we divide the $3,000 he has by the price per avocado. Yeah, so that gives us 1,200 avocados. If he spends all the money, then he can afford this much, this many avocados. So that's point B. Now C, if Russell buys 200 steaks, how many avocados will he be able to buy? Now 200 steaks, each costing $10, gives us this much price, or the expenditure. So that's $2,000 taken away from his $3,000 income. That leaves him with $1,000 now. So now divide this $1,000 by the price per avocado. That gives us 400 units of avocado. So that gives us this point C here, combining these 2 quantities. So that's 400 avocados and 200 steaks, point C. Now this is Russell's budget constraint. In other words, given his income, any point along this line is feasible to him. He can afford any point, any combination of or quantities of two products. So he may want to buy this much of this many of, let's say, avocados and this many steaks. Yeah. So along this curve, he can basically buy any quantities, any combinations, and he cannot, however, buy a point here because that's gonna cost him more than $3,000. So with his $3,000, he can afford, by spending all of the money, anything along this curve, any point along this curve, or anything inside this basically triangle. Yeah, this whole triangle. So this gives him a feasible set. Yeah. So this is a brief conclusion here. The budget constraint then shows the opportunities available to consumer. So given the budget, he can take advantage of all the opportunities within this triangle. It is drawn given the consumer's income and gives the price of two goods. So that's the budget constraint in a nutshell. So let's say right now Russell is at point C. He is basically consuming 200 steaks and 400 avocados given this point here. Now he would like to move along this curve to D, point D here. So point D right here gives him 800 units of avocados and 100 units of steaks. Now let's say by moving from C to D, he will gain 400 avocados, but at the same time he's going to lose, so the difference between 200 and 100 is 100, so 100 steaks. So basically he is giving up 100 steaks in return for 400 additional avocados. If you look at the math of this, it's basically rise over run, yeah, the slope. Let's look at that. So rise over run. So what he's doing is he's gaining a 400 avocados, but he's giving up 100 units of steak. So that ratio gives us exactly -4. So this means the cost of a single steak is 4 avocados. Yeah. In other words, to gain 4 avocados, he's giving up 1 steak. So that slope gives us the opportunity cost. In other words, the opportunity cost of this 4 avocados is 1 steak, or the opportunity cost of the steak is 4 avocados. Yeah. Also, the relative prices can give us the same result. So remember what the prices were. So price of avocado was £2.50 per avocado, and price of steak was £4. Remember? Sorry, apologies. This is £10 here. £10, yeah. We get exactly the same result if we simply calculate the relative price here. So the slope is basically equal to 10 over 2.5, and that gives us 4. So the cost of steak is basically 4 avocados, or the opportunity cost of a steak is 4 avocados. Yeah, to get 4 avocados, he's giving up 1 steak, or to get 1 steak, Russell will be giving up 4 avocados in this case. Yeah. Now we will demonstrate how budget constraint can be changed when income changes or when prices change. So let's look at this example here. And so there is an initial problem here that the Russell's income was in fact $3,000, and the price is $10 per steak, and the price for avocados is $2.5. We will now look at what happens to the budget constraint if, let's say, Russell's income falls to $2,000. Second, we will look at the change in budget constraint when price of avocados rise to $4 per avocado. Yeah. So let's move on. Now we'll start the discussion with the answer to question A. Now remember that A said what happens to budget constraint when Russell's income goes down to $2,000. So we need to calculate the extreme points again. First we calculated for avocados. $2,000 divided by 2.5 gives us 800 avocados. So this is this point here. So let's say this is A prime. And what if Russell spends all the money buying steaks? Then he ends up on the other extreme, so he gets 200 steaks only. He doesn't get any avocados. That's point B prime. Now this would be our new budget constraint. Remember, the area now is now what we call the feasible set. Basically, it contains all the feasible set, but the optimals lie usually along the optimal choices lie along the what we call the constraint, yeah, budget constraint. But this, as you can see, this whole set has now the triangle area shrank because Russell now has lower income. This conclusion here is that with the budget changing or shrinking, the opportunity sets also shrink as well for Russell, and a reduction in income shrinks the shifts the budget constraint to the left. And similarly, if we were to start from this point, from this small budget, and Russell's income increases, then we would see the budget would have shifted to the right, yeah, in the same fashion, yeah. So that's the idea here. So income shifts the budget line, means I should say constraint line, yeah. Now, to answer the second question, so it's about question B, where price of avocado increases to $4. So this is in dollars. 3,000 budget is still there, so that's income Russell earns. Now with his $3,000 income, he can still buy 300 steaks, because question B didn't say anything about the price of steak. So price of steak is still constant or remains there as $10. Yeah, we are still at this point. Let's say B. This was B, wasn't it? B prime or B. Then, however, if he spends all the money buying the avocados, then, well, he's gonna get 700 avocados, but no steak. Yeah. So 3,000 divided by 4 gives us 700 units. So now this point now shrinks, basically comes down to 750. This is point A, let's say prime, point A prime here. So there's a pivot, yeah, around the point B. So point B is not going to change. We don't move it because the price of steak didn't change, but the price of avocados changed, and that meant that but in fact this is an increase, yeah. So price of avocados increased. As a result, now Russell can afford fewer avocados only, yeah, given the change in the price of avocados. Now notice this again, there is a shrinking in the area here. So the budget or opportunity set has declined for Russell, yeah. So concluding remarks here: an increase in the price of one good pivots the budget constraint inwards, yeah. It just pushes it downwards, either this way or that way. You can test by changing the price of steak, let's say to 15. You can just do the analysis, and you will see that with an increase in price, this point is also gonna move inwards to this point. When it's 15 pounds, $15, we should get this set, yeah. So this quantity of steaks, that then gives us, assuming that the these avocados remained at $4, this would give us a new budget constraint here, yeah. So that will be our new budget constraint, yeah. So with inflation, our purchasing power has been eroded, yeah. Is now, it has become even smaller, yeah. So similarly, with a decrease in the price of a good, we will have a pivot in the budget constraint upwards, yeah, or outwards, yeah. So if we were initially here with a reduction in our let's say in the price of steaks, we may be able to afford to buy more steaks. So that maybe this is the point. Next point is, so if we assume that avocado prices don't change, then we get a new budget constraint all somewhere there, yeah. So we would like to learn about how consumers make choices or decisions on the choices. So budget constraint was one piece of information that was useful in our analysis, and also the prices. However, consumers' choice depend also what they prefer, their preferences, yeah, given the budget constraint as well, yeah. So let's look at this next piece of analysis, where we introduce something called indifference curves. What are the indifference curves? Basically, indifference curves show us different bundles of goods for which we get exactly the same satisfaction or utility. Yeah. So let's say maybe there exists this set of bundles that give me exactly the same satisfaction. Let's say with an example, so say that I usually get with 10 pizzas and two cans of Pepsi, 10 utils, and then let's say 3 Pepsis and 5 pizzas would also give me exactly the same 10 utils, and also 1 pizza and 10 Pepsi cans of Pepsi also give me exactly the same utils. So this when I plot these points, along these points I am indifferent basically. So because this combination of goods give me exactly the same util, or what we call satisfaction. The utility is just a nice jargon to describe satisfaction. It also describes happiness, right? So keep this in mind. Quite often we will refer back to utility, but we simply mean satisfaction with that word. Yeah. So briefly about the utility here. The total utility is the total level of the happiness or satisfaction from consuming a particular good, for example. Yeah. So marginal utility is the additional utility that we get from let's say consuming that additional unit of good. Yeah. So here's a good example. The first column here shows us the number of slices of pizza. Second column is total utility column, and then marginal utility column. So let's look at this first one. When we have 0 pizza, then obviously total utility is 0, there is no marginal utility. But when you consume the first pizza, we have 70 as a total utility, and the marginal utility from moving from 0 slices to one slice gives is a 70 utility. Yeah. So this is the marginal utility when we move from 0 to 1, and which is first units are usually giving us exactly the same total utility and the marginal utility. Now when we consume the second unit together with the first unit, the second unit gives us 110 utility. Yeah. So the total utility is 110. Usually this is called utils. Yeah, 110 utils, but just for the sake of simplicity I will continue saying utility. Yeah. So the total utility here is 110. The marginal utility now is 40. So the difference between 110 and 70 is 40. So that one additional unit of slice of pizza has given us 40 marginal utility, yeah, additional utility. Now we add the third pizza slice, and together with the previous 2 pizza slices, the third slice gives us 130 total utility. Now this is a jump of 20 points, yeah, 20 utils from previous consumption. So notice this marginal utility is increasing. However, and as we consume more pizza slices, we are getting less and less marginal utility. So in other words, marginal utility is decreasing. However, you will see that the total utility increases. We are still gaining some utility, but that gain is diminishing with extra units of pizza. Now we will define the law of diminishing marginal utility. So that is, it says marginal utility declines as more of a particular good is consumed in a given time period, holding everything else constant. Yeah. So it's like drinking water. First cup is usually gonna give you a nice satisfaction. You drink the next cup, you get still satisfied, but then third and fourth and fifth cups will certainly start giving you less and less satisfaction. In fact, you will not really enjoy drinking more, so that gives you a negative marginal utility. So you are still enjoying with this additional slices, similar to the water example, but eventually you feel sick, yeah, by consuming a lot of this, more of this, let's say pizza. So we just introduced a few concepts which will be used in our future examples. Now we will continue with Russell, yeah, our original example, to demonstrate the indifference curves. Let's define them first, and remember, indifference curve shows us the combination of goods, in this case 2 goods, that give us the same range of combination of goods that give us the same satisfaction, the same level of satisfaction. So here we have two indifference curves, and the example states here that the points A and B and all other points on indifference curve I1, so this is I1 here, give us exactly the same level of satisfaction, where the Russell is at this point A here and consumes this much of avocados or this much of steak, we'll get a level of satisfaction equal to the point or equal to the satisfaction that he gets at point B. So this much and this much satisfaction. Yeah. So it could be this. He could prefer being in this point here or that point, anywhere on the I, basically I1. He gets exactly the same satisfaction. Now, along the I2 curve, he also gets sort of exactly the same satisfaction or utility. So any point along this curve is basically giving him exactly the same satisfaction as point C. However, when you compare these 3 points A, B, C, Russell prefers point C because point C lies on the higher indifference curve, yeah, higher and to the right, yeah. So Russell prefers consuming the combination of goods along this curve because I2 lies above I1, and that means there is more utility along I2. So the next concept here is the marginal rate of substitution. The marginal rate of substitution is the rate at which consumer is willing to trade one good for another. Basically, it's the same as the budget constraint case here. The marginal rate of substitution is the slope of indifference curve. What it shows us is that Russell here will be happy to, let's say, swap 4 avocados with 1 pizza. The reason is at point A, he's got more avocados, yeah, related to steaks. Let's move down along the curve. So at this point here, he's only happy to trade 1 avocado for 1 steak. He has fewer avocados relative to steaks. He values the avocados more relative to the steak. In this case, obviously, they're equally valuable for him. But when you move back to A, you will realize that he values steaks more than the avocados, so he's happy to give away more avocados for 1 scarce pizza he has. Yeah. So as we move down, the slope. In fact, this marginal rate of substitution reflects the slope of the indifference curve. In this case, it's a steep slope. Yeah. So I can draw it here. You can see that this line, if it were a straight line, it's just tangential at the point A to this indifference curve. This slope is basically steeper. Now here the slope is not steep, yeah, the slope is not steep, yeah. So this is a tangent point here. So at this point he values avocados as much as he values the steaks, yeah. So that's the idea here with the marginal rate of substitution, and it changes along as we move along the indifference curve. There are 4 properties of indifference curves, so we'll discuss these one by one with examples in a minute. So let's state them first. This will be useful in our analysis later. So higher indifference curves are preferred to lower ones. So people usually prefer to consume more of goods than less, yeah. And high indifference curves represent large quantities, as we saw earlier, yeah. Consumers would like to be operating along the high indifference curves. Next property is that indifference curves slope downwards. This leads us back to the marginal rate of substitution case, or the slope of the indifference curve. This has an important implications. We know that to gain more of something, we have to sacrifice some goods. Yeah, so that downward slopeness basically reflects that idea. Third property is that indifference curves do not cross. Well, I will show you with an example. This is an important one. Indifference curves, when they cross, this contradicts the first property. Now, number 4, indifference curves are bowed inwards. Now, this is also a nice property. It reflects the something that we usually have in real life, opportunity costs. Yeah, it reflects opportunity costs. So people will be basically with the bowed inwards case, depending on how much of of a product you have, your opportunity or your willingness to trade them with other goods will change. Yeah, so if you have abundance of something, you will be willing to exchange a lot of this thing for just a single item of another thing that you don't have. So let's give examples for this cases. First, we'll start with the downward slopedness. If you remember, we said any point along this curve I1 gives us exactly the same satisfaction. So if we move from point A, so let me just get this. If we move from point A here, which gives us this much of avocados, A prime, and this much of steaks, gives us a certain amount of utility. But if we move down here to B, what we're doing here is that we lost certain amount here. So we lost that much of avocados, but we gained that much of steaks, yeah? So we're giving up some of the items we already had in order to gain some of the items that we didn't have. So that slope reflects this trade-off here, right? So Russell would be equally happy at point A or B because whatever he's lost is being compensated by whatever he's gained here. Now, both inwardness is an interesting property. Because Russell at this point has a lot of avocados, he will be happy to exchange additional unit of steak, more of avocado. So in this case, marginal rate of substitution is equal to 4, which means then to gain a unit of steak, he's going to give up, give away basically in exchange 4 units of avocado. However, at point B now, notice that Russell's circumstances have changed and he's got fewer avocados but more steak now. So at this point now, he will not be happy to give away more avocados because he's already got fewer, and then giving fewer is basically going to cost him a lot. So just to gain 1 steak again here in this case, he will be only be giving away 1 unit of avocado. Given that it's going to cost him huge, the opportunity cost of doing that will be higher, yeah. So he will be basically at this point craving for avocados, yeah. So instead, he would be happy to give away more of steaks in return for fewer avocados if he's at point B. But remember, either point A or B will give exactly the same utility level, yeah. This is about the ranking. If you remember, we said we prefer, as a property 1, we prefer operating along I2, certainly not I0, because I0, while it gives, let's say, 10 levels of satisfaction, to make it simple, this gives us, let's say I1 gives us 20 here, 20, and I2 gives us, let's say, 30. So given this higher satisfaction levels along the I2, I prefer point C over A, or certainly over B, yeah. High indifference curves usually reflect higher quantities, yeah. So notice that at point C, I get more of that and also more of that. But point B, more of that, but very few of this. Point A, okay, equally, well, similar quantities, but then I still prefer C because I get more of both goods, yeah. Well, point C is preferred over B or A. Say we are on point B now, and Russell would prefer point B because it has higher quantities of both of avocado and steaks, yeah, steaks, compared to point C, which has fewer steaks and also fewer avocados. However, it turns out when you look at the point here, A, you would realize that it lies on I1, sorry, in this case I4 for some reason. This should really be I2. Yeah, so it lies on I2 and also on I1. So this point is on both lines. That means, well, he would be indifferent between C and A. He would also be indifferent between B and A. Well, that doesn't make sense, because if he is indifferent between C and A and B and C, then he should be indifferent between B and C, because then, well, this doesn't make sense, because point B certainly gives more of both A and B. However, when he is indifferent between C and B, it should be slightly different, because B and that would be he should basically have one of fewer of something, let's say A, and then more of S in that case. But here, when he moves from C to B, yeah, try to move here, yeah. When he does that, he's gonna get more of each one, yeah. That doesn't make sense, because we said when you move along, if you're indifferent between the goods along this curve, let's say, yeah, between C and A, when you move from C to A, you certainly lose some amount of avocado but gain some of steaks, yeah. However, the same logic doesn't apply here, because moving from C to B results in increase in both items. Now next we discuss the optimal combination of two goods. So far we looked at various combination of goods that we can purchase given our budget constraint, and we also discussed indifference curves, various combination of two goods that give us exactly the same utility. We might say, what's the optimal combination then? How do we find it? So it turns out the optimal choice is at the highest indifference curve. It's a point along the highest indifference curve that we can attain. It will give us the best possible combination of two goods. Now it turns out the optimum is where marginal rate of substitution is equal to relative prices. And remember, marginal rate of substitution was the slope of the indifference curve, and relative price is where the slope of the budget constraint. Yeah, so right, so we're going back to Russell's optimal bundle now, or we're going back to Russell's example, and we'll help Russell to find the optimal bundle. Let's call it I1. Along I1, Russell will be indifferent between any of this, along this curve, any point, yeah. And also this I2. However, I1 is not preferred when there is I2, yeah. So I2 is at a higher is a higher indifference curve, and it allows Russell to choose higher combinations of good avocado and steak. And the third indifference curve, I3, is even better. It's better than the other two. It basically combines points that allow Russell higher utility. Yeah. So let's say this is a 100 utility. This is let's say 50. Let's say this is 10. In that case, the question is, where is the optimal point now? So we have 3 points here. Russell certainly can afford point C and also point D. However, remember, the property of indifference curve is that we prefer the combination of goods that are at the higher indifference curve. So with this point C and D are within the reach of Russell's capabilities. In other words, he has the budget. Basically, he can consume any of these points, yeah, and he can consume 400 units and then of avocado, and then 130 units of steaks. Or at the same time, he's indifferent as well as to choosing D. So because these are all in the same curve. So however, problem is that he's not going to get a high utility here. It's only 10 utils, yeah. With indifference curve 2, he would be better off because it gives him 50 utils, yeah. And notice this point A is along this I2 here, and he certainly prefers A to C. Well, he certainly would have preferred B to A as well, but B is not attainable because his budget is constrained, and so he will have to choose a point along I2. And it turns out he would be happy to get this as well, yeah, to get, let's say, point D here, but then this is outside his budget. He can choose this point and say this is D prime, but still it's out of reach for him. He can, however, choose A because it's within his reach, it's within the budget. So this combination of goods can be purchased using his $3,000 budget. He would also choose this point because he would be indifferent between A and let's say D double prime. However, that point is beyond his reach. Again, this budget line is below that point. So it turns out he would have to come back to A again, given his budget line. So it turns out to be the optimal choice or optimal point here that combines 600 units of avocado and 150 units of steak. Mathematically, we can describe this optimal decision. MRS is equal to price of steaks over price of avocados. Yeah, we can rewrite this equation slightly differently here. If I can scroll down a bit. Now, marginal rate of substitution is basically equal to marginal utility from consuming X. In this case, it will be steak, over marginal utility of consuming from consuming an additional avocados. So when we equate these two, what we get is price of S over price of A, and a bit of what we call rearranging gives us MUS over PS equals in this case we now move MUA to the numerator of the other side, so MUA over PA. So this would be our nice sort of equality. It has a nice interpretation. So at this optimum, the margin utility per dollar spent on steak equals the margin utility per dollar spent on avocado.